My name is Tammy Miller. In this video, we will learn to analyze SN2 solvent conditions. To analyze SN2 solvent conditions, we first need to understand a little bit about the solvent and the SN2 reaction. SN2 reactions require an aprotic solvent. The reason they require an aprotic solvent is first, because they do not proceed through a carbocation intermediate. What this means is the carbocation intermediate does not need to be stabilized by hydrogen bonding. Therefore, protic solvents are not needed to hydrogen bond with and stabilize the carbocation intermediate because there is no carbocation intermediate. Next, SN2 reactions always require a strong nucleophile to proceed forward. Because of this, protic solvents should never be used in the presence of a strong base. As we have a strong nucleophile, this is also going to be a strong base. This nucleophile will attack and deprotonate a protic solvent instead of attacking a substrate. In other words, if I have this hydroxyl group, it is much easier for a strong base to take this and grab that proton instead of attacking the substrate. Due to this, we always want to make sure that we do not have a protic solvent around, and we always use an aprotic solvent. Let's go ahead and look at a question based on this. During an organic chemistry lab final, a student is presented with two solvents and asked to complete an SN2 reaction. To proceed, he must tell the TA which solvent he will be using. Which solvent should he choose and why? So first of all, I see that my student is presented with ethanol and DMSO. I need to determine if these are protic or aprotic to determine which one he should be using for an SN2 reaction. First, if we look at ethanol, we notice that ethanol is a protic solvent. It has this hydrogen right here that can easily be removed by the very strong nucleophile, which is a very strong base. Because of this, I don't want to use ethanol so that the nucleophile actually attacks the substrate instead of deprotonating the solvent. The second solvent that was presented is a DMSO. DMSO's structure has a sulfur double bonded to an oxygen and then single bonded to two methyl groups. Here, I do not see a hydrogen attached to an oxygen. That means that there is no hydrogen that can be released to the solution. This is an aprotic solvent. This is the correct solvent that I would like to use to make sure that an SN2 reaction proceeds. Understanding the solvents that we are given with an SN2 reaction allows us to understand if we will have an SN2 reaction that proceeds or not. This will make our organic chemistry a little bit easier.